Hello, my dear students. Hello, everyone, and welcome back to the waves. This session, we're gonna have a practice on wave problems, calculating the wave velocity, the wavelength, the frequency, and the periodic time. As an example, train emits sound of wavelength 0.6 and frequency 550 Hz. Calculate the velocity of the sound. Applying the formula V equals lambda times nu, then V equals 0.6 times 550 equals 330 meter per second. Okay, and then number 2, you have to try it yourself. Okay, the next one, a vibrating string makes 0.001 second to move from the rest position to the maximum displacement. Distance from the rest position to the maximum displacement is called amplitude, as shown when a pendulum moves from here to there, making an amplitude. This makes 1/4 of a cycle. Applying the rule, nu equals n over t, then quarter divided times 0.001 equals 250, of course. If you'd like to find the periodic time, as shown, 4 times 0.001, and then find the frequency as the reciprocal of the periodic time, it's also okay. Then move to number 11. An oscillating source of frequency 100 Hz. Find the time between the passage of the first and the 20th crest. Then the number of waves equals 20 minus 1, 19 waves. So simple. Frequency equals number over time. Then we can get that the time equals number over frequency. So 19 over 0, sorry. The number is 19 over 100 equals 0.19 second. Then let's move to number 12. Number 12, the time passed between the passage of trough of the first wave and the crest of the 7th wave. With a point along the path of a transverse wave is 0.11 second. Then the time is given as 0.11 seconds. And now what about the number of waves? We can analyze the given data as the following. From the first trough to the second crest, it means half wave. And from the second crest to the 7th crest, it gives out 5 waves. Then the number is 5.5 waves. Simply, we can calculate that frequency equals number of waves over time. 5.5 over 0.11, we get it as 50 Hz. You can try number 13. Number 14. Tuning fork. with frequency vibrates near an air column of length 12 meter. Of course, it's the distance. The first wave is formed at the beginning of the column reaches its base when the fork starts to produce the 13th waves, which means that this is the air column. Here is the first wave passing in the following direction as the tuning fork, which is here, starting to produce the 13th wave. This means that the number of waves is 13 minus 1 equals 12, and then wavelength, frequency of course equals 320, and the wavelength equals distance over number, and then 12 over 12 means 1 meter, and then we come to the frequency times wavelength to find out the velocity. 320 times 1 equals 320 meter per second. Let's start number 26, two tuning forks, 600 and 400 hertz. The wavelength of one of them is longer than the other by 0.8. It means 0.8 meter, of course, which is the 80 centimeter. Calculate the wavelength of the two waves and the velocity. Okay, knowing that they propagate in the same medium, kindly remember that same medium means same velocity. Okay, then V1 equals V2. Therefore frequency 1 lambda 1 equals frequency 2 lambda 2, and then frequency is inversely proportional with the wavelength in the same medium. Therefore frequency 1 is greater than frequency 2, then wavelength 1 is much less than wavelength 2, then lambda 2 equal lambda 1 plus 0.8. Okay, substituting in this equation, 600 lambda 1 equal 400. Instead of lambda 2, we can write lambda 1 plus 0.8 using the distribution method. 600 lambda 1 equal 400, lambda 1 plus 400 times 0.8. Move this to the other side using the negative sign and calculate lambda 1, lambda 2, and calculate the velocity. And that was all for the practice of the waves. Waiting to see you in the class to recheck your homework till the end of the chapter and start a new chapter. Thank you and stay safe and bye-bye.